peeps, it's Julian here from Disrupt Tutoring, and as always, such a pleasure to join you. Today we're continuing with the Math Paper 2 IEB 2019 Supplementary exam, which deals with statistics. Okay, in question A, they've given us a table and they've asked us to determine the estimated mean for the number of liters used by an individual. So for this question, we'll first need to find the estimate total that of liters used. So how we do this is we take each data point, we find out the frequency and multiply it by the midpoint and get that total. So we can see that your total, estimated total, will equal that 2000 multiplied by 20, which is your midpoint, plus 3000 multiplied by 60 plus, and you do this for each line, and obviously you can also just put this straight into your calculator and continue. So 13,000 times that 140, it's going to go down here, plus 6,500 times 180 plus 2,500 times 220 plus 1,000 times 260. So doing all of this, so we get that this equals 472,000. So that's straight in your calculator, and this is your liters. And so they've asked us for the estimated mean, so your estimated mean will therefore equal your total divided by your cumulative frequency. So in this case, it'll be that 4,720,000 divided by, in the table, we've got this as the total cumulative frequency, which is 35,000. If I pop that into the calculator, I get that your estimated mean equals 134,86. Okay, and moving on to the next question. They're now asking us to draw the cumulative frequency graph. So I've put the table here just for reference. So the important things now we need to take note of is your sort of upper limit to each of the range. So for example, this 40 and 80, that's what you're going to be plotting against and keeping in mind your cumulative frequency. So for example, when there are when the range is 0, the frequency is obviously 0, so we need to start at a point 0 and 0. And if we have a look here, we've got now 40 and 2000. So at the point 40 on your x-axis, we'll need to estimate that 2000 is just under halfway between 0 and 5000. So we've got a data point over here. Then at 80, we've got a cumulative frequency of 5,000. So there's a nice point on the graph. It's quite clear. And if we continue in this, so 120 is at about 12,000. So that's just above the 10,000 mark. At 160, we have 25,000. So that's up there on the point. We continue now at about 200, we can see that should be 31,500. So on 200 over here, we have it at 31. So it's just above the 30,000 mark. And then of course at 240, we've got 34. So that's 1,000, which is just under that 35. And then at 280, we've got it on 35. So those are your main points. And now this is important. You just got to be as neat as possible. Make a smooth line that goes through all the data points. Cool, and that will give you your 4 marks. And C is asking us to determine the median number of liters used by an individual. And for this, we need to show on the graph where you read this value. So median is your middle number. That's how I remember it. So we need to find out of your cumulative frequency, which we know is 35,000, your median position will be at the halfway mark. So this would mean that it would be at position 17,500. So on your graph, you can see 17,500 is exactly in between 15,000 and 20,000. So if we read off here, by making a straight line from there, we see that this is the point we'll need to read off, which goes down to about the middle between 120 and 160 liters. So your final answer then should be at about say 140 liters. So your median equals 140, but depending on how you read it and how your graph was drawn, any answer between 125 and 150 would be acceptable. I've added question D, which asks us how many individuals use more than 220 liters of water? And again, we need to use our graph. So if we estimate that, so 220 on your x-axis is exactly between 200 and 140. And again, we use a ruler in your exam, but you draw a line going all the way to the top here. And when you get to, so that's the point, and now we use a ruler again to draw a line which goes to this, which is just above the halfway point. So I'd estimate that say that we read off, that's about 33,000. So now it asks us how many people use more than 220. So it's basically, what is this number between 33,000 and 35,000, which we can work out by saying your answer needs to equal 35,000 minus the number that you read off. Now, of course, you could have read off a slightly different number to what I read off, depending on how you drew your graph. But you should get an answer of plus or minus 2,000. Any answer within that range should be acceptable. Okay, moving on. Come to E, and it's asking, at the time of the survey, the max number of liters permitted per individual was 280. Now, if this restriction was to be reduced to 240, what would happen to the following? So before we read those, let's just try and visualize exactly what's happening here. So we remember that graph we drew. It looks something like this, where this was still 35,000. This was 0, and here was 280. So what they're saying is that if they have to restrict now this to actually 260, so what happens to the graph is it just becomes a bit thinner, but the shape will still remain the same, but it will almost look, because now it's been, all the top values have to sort of squeeze into a smaller range. This value here will now need to be 260, but this still remains the same. So, number one, what will happen to the median? Well, the median would, of course, stay the same. So it will stay the same, and the reason being is that only the top half, so because only the top half is affected, and the middle number will still be the middle number. So only the top is affected. So i.e. this, because remember, to get median you have to find this middle value where the start of this growing trend going up here is exactly the same if they had to reduce the max. So the median stays the same. And then it says what happens to the standard of deviation. Now this graph actually becomes thinner, which means that most of the values will start to squeeze closer to the mean value. So this means that the standard of deviation will decrease. And the reason being, as I said, is that the values will now be closer to the mean. So this just means that because now the range of possible values has decreased, it means that the likelihood of the values to be within a certain deviation is now decreased. And question number 3 asks us what would happen to the skewness of the data. So just visually looking at the second graph, we can see the top half is actually moving more towards the left. So this means that skewness is more towards the left. And so we can see that visually. So if we have to explain it, we can see that the top half is squeezed or moved more closer to the median or the middle of the graph. And that's your explanation. And that concludes question number 7. Before I go, as always, I'd like to thank our very special and epic sponsors for making this video possible. Read all about them in the description below. Be sure to visit our website for more of these epic tutorial videos. If you can't find your answer to a question, please just send us your question and we will respond with a personalized video just for you. And until next time, stay epic.